Hello, welcome to this AQA Further Math Statistics video, the third in the second series of videos on continuous random variables, further PDFs, this time looking at combining continuous random variables. So if we just do a little bit of a reminder from what you've learned in earlier videos. First of all, we looked at the expectation of a linear function of x, ax plus b, in terms of e of x as a, e of x plus b, and then the variance of ax plus b as a squared multiplied by the variance of x. And these rules would apply if instead of x you may have, say for example, x cubed. E of ax cubed plus b would be a e x cubed plus b, and the variance of ax cubed plus b would be a squared multiplied by the variance of x cubed. If we now look at sums of independent continuous random variables, we've got x and y with PDFs f of x and f of y, and the expected value of x plus or minus y is simply the sum of these two integrals. It's the expected value of x plus or minus the expected value of y. So e of x plus y is e of x plus e of y. E of x minus y is e of x minus e of y. And again, that's a result that you should know very clearly to use in the exam. When we have a look at, this time, the variance of x plus or minus y, the variance of x plus or minus y is simply the variance of x plus the variance of y. And that's because the variance of x minus y is exactly equivalent to the variance of x plus the variance of minus y, and variances are in units squared. They are always positive, so it doesn't matter whether our data is positive or negative. The distances the data are away from the mean are going to be squared, and they will be exactly the same. So the variance of x minus y is the variance of x plus the variance of y. So if you'd like to pause the video for a moment here, you could just read through the example here, giving you information about two continuous random variables, L and W. And we are given the information here that L and W are independent, and we've been asked to find the expectation of L plus W, which is simply the expectation or expected value of L plus that for W. And you may be able to see, if I just do this one for an example, we're going from 0 to 5. It's a continuous uniform distribution here. The mean quite clearly by symmetry is going to be 2.5. But if we just quickly, if I do one for you from first principles, the expected value of L would be the integral of L multiplied by the probability density function dl between 0 and 5, and that you should obtain 2.5 for. And similarly, the expected value for W is 5. So our expectation or expected value for L plus W is just 2.5 plus 5, or 7.5. If we now look at the variance of L plus W, that would simply be the variance of L plus the variance of W, and the variance of L would be the integral of L squared multiplied by the PDF dl between 0 and 5 minus at the mean squared. So e of L squared minus e of L, expected value of L, squared. And that you should be able to work out and find 25 over 12 for that variance. And the variance for W, similarly, you should obtain 25 over 3. And so the variance of L plus W is simply 25 over 12 plus 25 over 3. And that's coming to quite an awkward fraction, so it's probably better to give your answer to 3 sig figs 10.4. So if we now look at something slightly more complicated, we're now going to draw a line of length 2w minus L. So this time there's a subtraction involved here. We want first of all to find the expectation of that, and that would be twice the expected value for W minus the expected value for L, following the rules that you saw earlier. So that would be 2 times 5 minus 2.5, and that would give us 7.5. And finally here, if we look at the variance of 2w minus L, that would be the variance of 2w plus the variance of L, and that would be 2 squared multiplied by the variance of W plus the variance of L. And if you recall, the variance of W was 25 over 3, and the variance for L was 25 over 12, and that equals 35.4. So we've looked at the expectation and the variance for sums or differences of independent continuous random variables. It's a fairly sensible question to ask, what's the PDF of, for example, the sum x plus y? And remember, we could always be talking about a difference because that's just the sum of x plus minus y. And in fact, this for continuous random variables is beyond the A-level spec completely. So you're not expected to work with this in general, but you might like to look it up in a book, and you might want to investigate what something called convolution is in this case. A special case of sums of independent continuous random variables is when x and y are normally distributed, and in that case their sum, or indeed their difference, is also normally distributed, and that is a special case in the case that x and y are independent, normally distributed continuous random variables. And this will be something that we will use and will be important in the next set of videos. And that concludes this series of videos.